Hey, and welcome to The Explainer. So today, we're going to pull back the curtain on something you hear about all the time: artificial intelligence. And look, this isn't some far-off sci-fi thing, right? It's not magic. It's tech that's, well, it's already a huge part of your daily life. And today, we're going to figure out exactly how it all works.
So, have you ever been scrolling through TikTok and just thought, how does it know? How does it know exactly what videos I want to see? Or, when YouTube just serves up that perfect next video, it almost feels like it can read your mind, right? Well, that feeling, that's AI. It's right there, working behind the scenes, making these incredibly smart guesses about what you're going to love. And trust me, it's way more common than you probably think. I mean, it's in Siri and Alexa on our phones, right? It's the non-player characters in the games we play. It's those little chatbots that pop up on websites to help you out. It's even in cars now, with safety features that literally keep you in your lane. This so-called magic is absolutely everywhere. And yep, it all runs on artificial intelligence.
Okay, so what is it, really? Well, to put it simply, AI is all about building computer systems that can do stuff that normally needs a human brain. Things like recognizing your friend's face in a photo, or understanding a question you ask it, or even making a quick decision. The whole goal of AI is to give computers those same kinds of abilities. And you know what? This whole idea, it's not new at all. The dream of making intelligent machines, that goes way, way back to the 1950s. We're talking about pioneers like the computer scientist Alan Turing. He was already thinking about this stuff. He even came up with this really famous test, and we'll definitely get to that later, to try and answer the biggest question of all. Can a machine actually think? All right, so how do we go from just a basic computer program to something that genuinely feels intelligent? To figure that out, we've got to pop the hood. We need to unlock what people call the black box and really see how these machines learn.
The absolute key here is a concept called machine learning. See, instead of a programmer sitting down and trying to write millions of if this happens, then do that rules for every single possibility, which would be impossible, we do something different. We just give the machine a massive amount of data, an algorithm, and let it figure out the patterns for itself. It's kind of like how a little kid learns what a dog is. Not by reading a dictionary definition, right, but by seeing tons and tons of different dogs and learning the patterns.
Okay, so there are two main ways machines learn this stuff, and getting the difference is super important. First, you've got supervised learning. Think of this like the AI has a teacher. We give it a bunch of data that's already labeled, like thousands of pictures that are clearly marked cat or dog. It learns from these labeled examples. Then there's unsupervised learning. Here, there's no teacher. We just throw a whole mess of data at the AI, and its job is to find the hidden patterns all by itself. Like maybe grouping customers together based on what they buy, without us ever telling it what the groups should be.
But hell, how does a computer actually sift through all that information and find those patterns? Well, a lot of the really powerful AIs out there today use a structure that's inspired by, you guessed it, the most complex computer we know of, our own brain. And this structure is called a neural network.
Let's break that down. It's not as complicated as it sounds. You can think of it in three main steps. Step 1, the input layer. This is where the raw data comes in. So for example, every single pixel from a picture of a handwritten number. Then, step 2, that data flows through what are called hidden layers. Each layer analyzes the data, looking for more and more complex features. The first layer might just spot simple things like edges and curves. The next one might combine those edges to see shapes, like the little luke in a 9 or the straight line in a 1. And finally, after going through all these layers, you get to step 3, the output layer. This is where the network makes its final guess, its prediction. It basically says, okay, based on everything I've seen, I'm pretty darn sure that's a 9. But, and this is maybe the most important thing to remember about all of this, there is one golden rule for machine learning. It's an old saying in computer science: garbage in, garbage out. It means an AI is only as smart or as fair or as accurate as the data you train it on. If you feed it messy, incomplete, or biased data, well, you're going to get messy, biased results. The quality of that data, it's literally everything. Okay, so that's the theory, right? That's the how. Now let's connect all those dots back to the real world and see how this stuff is powering the things you and I use every single day. Okay, think back to what we just talked about. Remember Netflix? It uses unsupervised learning. It looks at millions of viewers and finds little clusters of people who like similar things. And that's exactly how it knows what show to recommend for your next binge watch. Now, a self-driving car? That's totally different. It uses supervised learning. It's been trained on millions and millions of images that are already labeled to help it spot pedestrians, stop signs, and other cars. And it's not just entertainment and transport. In healthcare, AIs that have been trained on thousands of labeled medical scans are now helping doctors spot diseases much, much earlier. It's pretty amazing.
All right, now for what I think is one of the coolest and biggest challenges in all of AI. Teaching your computer how to understand and speak our language. Yeah, human language. This is where things get really interesting. This whole field has a name. It's called natural language processing, or NLP for short. Basically, it's the part of AI that makes it possible for you to talk to a machine. We're talking about everything from that little chatbot that pops up on a website all the way to Siri or Alexa. NLP is the science of bridging that huge gap between our messy human language and clean computer code. And man, have we come a long way. The very first chatterbots from back in the 1960s, like this famous one called Eliza, were super simple. It would just find a keyword in what you typed, like sad, and then it would just spit your own sentence back at you, like, why do you say you are sad? There was zero real understanding there. Fast forward to today, and the systems we have now are just light years ahead. They can understand context, they can get nuance, and they can even generate completely new creative text on their own. And this brings us right back to where we started, with Alan Turing. He came up with the ultimate challenge for conversational AI, called the Turing test. It's basically a game, right? You have a judge, an interrogator, who is texting with two mystery players hidden from view. One is a real person, and the other is an AI. And the AI's goal? To be so good at conversation that the judge can't reliably tell which one is the machine. It's still this classic benchmark, and it all boils down to that one huge question. Can a machine talk so much like a person that you just can't tell the difference? Okay, so we've seen a lot of what AI can do. But now we need to switch gears and talk about maybe the most important part of this whole conversation, what AI should do. This is where we have to get into the big ethical questions and our responsibility as the people building and using this tech. So let's just dive right in with a really big one. Is it possible for an AI to be unfair, to be biased? The answer is a resounding yes. And this is a massive problem called AI bias. Remember what we said earlier? Garbage in, garbage out? Well, imagine this. You train an AI to help hire people, and you train it on a company's hiring data from the last 20 years. If that historical data shows that the company was biased in its hiring, the AI isn't going to magically fix it. Nope. It's going to learn that bias, and then it's going to start applying it automatically and at a massive scale. All right, next big question. Can an AI just make stuff up? Can it invent things out of thin air and state them like they're solid facts? Yes, it absolutely can. And there's a specific term for this. It's called an AI hallucination. You have to remember that at their core, these AI models are just incredibly sophisticated pattern matchers. They're built to predict the next most likely word or pixel. So sometimes, in trying to create a convincing pattern, they generate answers that sound totally believable, but are just wrong or completely fabricated. They're designed to be convincing, not necessarily to be truthful, and that means we always have to be critical and never just take what they say at face value. And it doesn't stop with bias and hallucinations. There are other huge questions that we as a society have to figure out, like data privacy. Where is all of our personal data going that's used to train these AIs? What about accountability? If a self-driving car crashes, who's responsible? The owner, the programmer, the company? And then there's the big one, jobs. How is AI going to change the future of work? These aren't easy questions, and they're really some of the biggest challenges we're facing right now. So let's end on this thought. This whole thing, it's not just about technology. It's about us. It's about our society. As this incredibly powerful tool gets more and more woven into our lives, the most crucial question we have to ask ourselves is, what are the rules going to be? What guardrails do we need to build? What values do we want to program into these systems to make sure AI actually benefits everyone and helps us build a future we all want to live in? That's the conversation, and it's one that every single one of us needs to be a part of.